So I decided to continue on from yesterday just because it seemed like you guys were okay on the first derivative test, but we also didn't really do it on, very many types of problems. We mainly only did it on polynomials, and absolutely you can get quite a bit more difficult equations to do it on, so I thought maybe we should do a couple of those today. Thank you, Michael. How on earth did you know it was my birthday? Oh, yeah. Thank you. Look at that. I did not take the day off this year for you guys. I usually take my birthday off, but I knew it wouldn't go very well since we don't have many days. So you guys should feel special. Thank you. So I decided we'll do the thank you, Michael. I decided we'll do the problem we ended with yesterday. So we went through this work yesterday and we found the critical numbers, and I don't know if we even found critical points. I think we just found critical numbers. But the zero was the one I kind of put it up there. Don't worry, Tara, we are ending early today. I was not going to go full hour. You guys have a 4-day weekend, so. The zero was the one I ended with. Shoot, who did I just let in? Oh, Keenan. Right? Yeah, Keenan. I put up this problem yesterday because the zero was like the first example we've had where it was a critical number, but it wasn't going to be an extrema because it's not an actual point. The zero was a vertical asymptote. But you still use it because it's a spot in the function where stuff changes. So that's why it's called a critical number. So let's make the number line, because it sounds like everybody liked the number line better. So on the number line, we are going to put the critical numbers, because critical numbers are what separate everything. All right, so we've got 3 of them this time. And they're actually pretty close to each other, but I'll spread them out here. So we have 3 critical numbers, which means we have 4 sections that we need to test. The whole point of the first derivative test is to figure out where our graph is going up and down, so increasing and decreasing sections. And then the way we do that is we pick a random number in each section, and this goes all the way to infinity. The number lines don't have to go forever both ways. Sometimes you are given constraints to start with, especially trig. Trig, they'll usually give you a set number line spot. So let's see, what should I pick? I'm going to pick, I have to plug it in this first derivative. Why don't we pick -2? That might be small enough that it'll work. So -2, the top of the fraction, 15 times 2, I get a positive number on the top of the fraction. On the bottom number, I get -8. So remember, I only care if the answer is positive or negative. I don't actually care what the slope is. So positive divided by a negative would give me a negative slope, which would be a decreasing section. So I'm going to label this minus. And then I'm going to specifically just pick a number from each section. And this is where it usually goes horrible. Like when you have to pick like halves. But at least we only need to figure out if it's positive or negative. So if I plug negative half here, negative half to the fourth would be positive 1/16. Minus 1 would be a negative number. Times 2 would still be negative on the top of the fraction. On the bottom of the fraction, negative 1/2 cubed would still be negative. So I would end up with a positive slope, which would be an increasing section. So this whole section is increasing. And then sometimes these are just flat out time consuming because there's a lot of stuff to do. Positive 1/2 would be negative on the top, positive on the bottom. 2 would be positive on top, positive on the bottom. Now this one alternated. They do not have to alternate. Once you figure out your first derivative test table, then you're going to identify, you know what, I didn't even write directions on this one. This one, we'll just do maxima. I'll save the intervals of increasing and decreasing, I think is on the next problem. So if I plug negative 1 into the original function, which we already did down here, I'm going to find the point negative 1, 2. And if you recall, because it is changing from decreasing to increasing, so decreasing, increasing, that's a min. So negative 1, 2 is a relative min. So this would be one extrema. 0 isn't even a point. This is a vertical asymptote. Because it's not a point, it can't be a min or max. There's really nothing to test. I mean, it looks like it should be a max because it goes increasing to decreasing. But it's nothing because it's a vertical asymptote. And then 1, 2 goes from decreasing to increasing, just like the other one. So this is also a relative min. So this particular problem has two relative mins, no relative maxes. And you know what? I was going to say, I think I had the screenshot, which ended up being really big. If you were to graph it on your calculator, you would find that it looks like this. And this information that we found fits it, because you can see that it goes down, comes up, vertical asymptote, down, up. We have two relative mins. And that could be a way you could always check yourself, like if you want to know if you're doing it right. Okay, so this was a refresher of what we were doing yesterday. I thought this would be a good point, good time to have you guys try one on your own. Now, it's okay if you don't know how to write the answers for the intervals of increasing and decreasing yet, but I wanted you guys to see if you could find all of the extrema. This would be a perfect point for me to go get something more to drink. So this might be a good point for me to start going through this, because I don't know if you got stuck on solving the derivative or not. Because the one really big downside to these questions, if you get the critical numbers wrong, everything else is wrong. So that's why the more I thought about it here, I should probably make sure you have the critical number part right. So we needed to solve this equal to 0 or undefined. I feel like we had one almost exactly like this the other day. Divide by 2. So there's different ways to solve this. I wanted to write it like this because I'm guessing you guys can see on this step x can't be 0. That makes it a critical number. So if I keep solving this to find my zeros, so multiply both sides by cube root of x. Cube both sides. I don't think this is the same one we had the other day, but I think I was awfully close, because I think that one was, oh God, that's what happens when you talk while you write. You only get regular 1. So x equals 1 is a critical number. If you want to go through the work to find the points right away, you can. It really doesn't matter when you do the points. So I usually just do it now before, then I can kind of focus on making the table, but it doesn't matter when you do it. So I'm going to plug 0 into the original function to see if it's a point. 2 times 0 minus 3 times cube root of 0 squared is still 0. So 0 minus 0 is 0. So the point 0, 0 is a critical point. I can't unsee the face ever since I read 0, 0 now. F of 1. What do I get? I get 2 minus 3 times 1, so negative 1. So I've got 2 critical points. So it's quite possible I'll have 2 extrema, but it doesn't have to be. Anybody want to ask any questions on this? I'm definitely guessing some people forgot 0. That's why I wanted to put this up here. Because your table or your number line looks very different if you do. Oh, that's not a line. I forgot to click the line tool. Okay, this one was all real numbers. I'm only going to put 0 and 1 on here. Let's see, my derivative is negative 1/3. So let's pick some numbers that work well with cube root. So let's do negative 8. Prime. Sorry, I forgot to write prime. If I plug negative 8 into my derivative, this would be 1 over cube root of negative 8, which would be negative 1/2. So 2 minus 2 times negative 1/2 would be 2 plus 1, or 3, which is positive, and that's an increasing section. Wow, cube roots. I guess I can do 1/8. And 8. I'll just kind of keep picking the numbers that fit with it. I mean, if you have a calculator, obviously it doesn't matter what you pick, but I didn't want to use one. So 1 over cube root of 1/8, would be 1 over 1/2, which is 2. So 2 minus 2 times 2 would be 2 minus 4, or negative 2. So decreasing. 8 would be 1 over 2, 1 over cube root of 8. So 1 over 2, 2 minus 2 times 1/2 would be 2 minus 1, or 1. Still increasing. Okay. If I so this one alternates, so it looks like both of these critical points are going to be something. So at x equals 0, point 0, 0 goes from increasing to decreasing. Which would make this increasing, decreasing, a relative max. So there's one answer. 1, negative 1. Well, that goes from decreasing to increasing. That makes that a relative min. Okay, these are all the extrema. So that was that question. The intervals of increasing, decreasing is actually much easier. If we were just to do the intervals of increasing, decreasing, we basically don't have to do anything with what's written in yellow. Because increasing and decreasing is just to say where it's increasing, decreasing. So like we could say f of x is increasing from negative infinity to 0 along with 1 to infinity. And f of x is decreasing from 0 to 1. Now on the interval notation, the only time you're going to have a bracket is if, like, let's say this number line ended at a specific spot. That would be where you'd have a bracket. Otherwise, you're pretty much always going to have parentheses because you're always talking about in-between locations. So, anything on this one that maybe you guys want me to talk about or ask about? Or? It's not, actually. So in the original function, x to the 2/3 is like saying the cube root of x squared. So 0 can be plugged in there because you can do 0 squared and you can do the cube root of 0. If this was a negative power, then that would mean it's on the bottom of a fraction, and then 0 for sure would be an asymptote, or something or other. And I actually have the graph. Okay, I have the graph right here. What you're usually going to find is when there is fractional powers in a problem, it usually creates sharp points. So like this isn't a graph you would know what it looks like at all, but we would still be able to kind of find the information from it. Anybody else? I don't know. I don't know how this one ended up going for you. The fractional power ones can be kind of weird. Yeah, go ahead, Ellie. Correct. So, yeah. Oh, you know what? That's probably what. Okay. Yes. So you can't have x. You can't have 0 in the derivative because that basically means there's. Oh, that doesn't work with yellow. X equals 0 doesn't have a slope because it's a sharp point. So 0 is undefined in the first derivative only because it was in the denominator. But as long as you get a point in the original function, like it's not undefined, then it can be something. Yeah, I didn't even think. Yeah, I didn't even think about that. It matters where it's undefined. Yeah. Okay, let's go straight to the hard problem. We're going to skip the easy trig one. We're going to go right to the harder trig one. And when I say harder trig one, it's not a difficult trig one. It's just, you know, most of you just flat out aren't going to know what this graph looks like. So, but it is related to cosine. So at least the good thing is cosine is a continuous function, like it's the wave. So I know that there's not like asymptotes and things like that. So that makes it definitely easier. But on this one, we are given a set section to look at. So the main difference is our number line is going to be different. I know I told you the other day I would pick a trig one that had longer intervals. I just don't know if this is a good spot to do that. That might be overload on info today. Who should we go with? We should go with, what do you think, Emma? Emma, do you think you could help me solve the derivative? Or is trig like your archenemy? Oh, I can't hear you. Maybe your mic's working weird today. I mean, I see it's unmiked, but okay, that's all right. Yeah, it's working weird. No problem. Caduce? What do you think? Or maybe my computer's screwed up. No, it looks like I should be able to hear things. Whatever. Zoom might be goofy today. I'll just keep talking. I couldn't, Caduce. I couldn't hear you at all. So it 100% could be my computer. Who knows? That's all right. I know I heard people earlier, so I'll just keep going. No, that's all right. This one's almost ridiculous to try to. The hard part about calc is, unless it's a very simple question, it's stupidly hard to type out. I know from experience, because when I type up the tests, calc tests are very time-consuming to create. Even to, oh, that's sorry. You don't have to apologize for it. It's technology. It happens. So I want to set this equal to 0. Or look for undefined ones. And I know that there's no undefines because sine of x is continuous everywhere, just because it's like a wave function. If this was tangent, then I know there would be undefined values I'd have to look for. Now, the fact that we're trying to solve trig means that I'll need sine of x by itself equal to a number to solve it. So I would subtract 1, divide by 2. And I want to figure out where sine of x is equal to -1/2. And if you are a unit circle person, go for it. I'm not. I know how to use a unit circle. I just hate doing it because I just don't like having to look up stuff. So if I would draw my reference triangles, basically it can be one of these 4. Sine is the opposite side. And to get sine to be negative, that would be going down. So I know quadrants 1 and 2 are out. And I'm specifically looking from 0 to 2 pi because that's my interval. So that's why I kind of drew it like this. And to get -1/2, a 30-degree triangle has the ratios of 1 to 2 to square root of 3 in this arrangement. So these are both 30-degree angles. And, you know, calc angle is kind of like a sin word or whatever you want to call it. They strictly are radians, but in my head I think in degrees. So I know my two answers for x are going to be pi sixth past pi, and then pi sixth less than 2 pi. So that's kind of how my brain works. So that's pi sixth past, and this is pi sixth less than. So my first answer is 7 pi sixth, because this is like saying 6 and 12 sixths. So 7 pi sixth and 11 pi sixth. Now, other than the fact that you guys traditionally hate trig, this is where trig questions in the first derivative test sometimes are ridiculously bad. Because you sometimes have to pick values that are in between like what you actually know. Like, it's almost like you're forced to use a calculator sometimes. This number line goes from 0 to 2 pi. Now, if I were to draw this, kind of scaled correct, 7 pi 6 is right here-ish. 11 pi 6 would be over here-ish. Now, you don't have to make them to scale. I'm just kind of doing that for your benefit. But our sections are what we have to test. And right over here is where I'm talking about that doesn't always mesh well. Like, it's not hard for me to find a first derivative number to plug in from 0 to 7 pi 6, like pi. Same with 7 pi 6 to 11 pi 6. You have lots of choices. I'm going to pick 3 pi halves. But from 11 pi 6 to 2 pi, you would have to use your calculator. And I don't like that. So do know, like, when I try to set this up for you, I'm going to set it up so that... Oh, yeah. So for the table for this one, you're not going to be expected to be doing a first derivative test by hand if you get something like this. This might be something where it might say calculator loud, but generally not, because if you have a calculator, like, all of this work is kind of useless anyway, because you can just do it on the calculator to start with. So this one wouldn't be a normal by hand one. So Mandy, when you say the table, you mean like the actual table? Yeah. So since everybody kind of said that they liked the number line better, I figured what I would try to do, is I would try to work with the number line for now, and then as we get closer to the AP test, kind of switch to table format once everybody was more comfortable with it. But the table would look like this. Okay, if I plug pi into my first derivative, sine of pi is 0, so I get a positive answer. So it's a plus section. If I plug 3 pi halves in, sine of 3 pi halves is negative 1. So this would be 1 minus 2, or a negative section. And I'll just tell you right now that if you use your calculator to calculate 1 plus 2 sine of 6.23, because that would be slightly less than 2 pi. So sine of 6.23, you're going to get a positive answer. So I'll just do that. I basically know this because sine alternates. So it's kind of a normal function of sine. The table method we would say f prime of pi is greater than 0. We would say f prime of 3 pi halves is less than 0. F prime of 6.23 is greater than 0. So these show the same information differently. And then you basically figure out if it is increasing or decreasing. And that's the pluses and minuses are the same thing. And then you figure out extrema from this. Well, our first extrema would be at this location. You know what? We didn't do the points earlier. So this is the point 7 pi sixth something. This is the point 11 pi is really hard to write. Something. If I would plug these in the original function, oh, this is not fun to do in my head. 7 pi 6 goes in place of x, minus 2 times cosine of 7 pi 6. At least I still have the drawing right here, so cosine. Cosine is going to be negative square root of 3 over 2. Those cancel. So this is the point 7 pi 6 plus square root of 3. I know that it's super hard to read, and I'm sorry. If I plug 11 pi 6, I would get 11 pi 6 goes in place of x, minus 2 times cosine of 11 pi 6. And cosine would be positive square root of 3 over 2. So this would be 11 pi 6 minus square root of 3, and it probably just looks like jumble to you. But this is going to be a relative max because it all changes from increasing to decreasing. This is going to be a relative min because it changes from decreasing to increasing. Now, because of the... Oh, you know what? I'll pause that. Do you guys want me to answer anything out here? Or is this more of a case of you get the ideas behind this, it's just kind of probably... It's going to take you longer to do it because doing the trig part of it goes slower for you? Might be it. I mean, that'd be okay. It's just you have to work through it, I guess. Okay. Yeah. Well, it's... Yes, it's a lot of info. This is where I was going to stop today. Now, in terms of homework, you guys will probably have noticed that, like, we're not very far in the Khan Academy list of assignments. And that's okay. I think it's better to learn it in kind of the amount of time and order you need to learn it. You don't, Ellie. You don't get a unit circle on the AP exam. However, I actually don't know how they're going to do it this year. They actually just announced yesterday what they're doing. The first test in May is a paper test that you come into school for. The second test in May is a paper test that you come into school for. The third test in early June is an electronic test that you take at home. So I really honestly don't know how they're going to be setting them up so that they're equivalent. On the paper test, you're not allowed anything, and they don't usually give you a unit circle. Last year when they did the electronic test, the test had a 100% different setup than normal. and there were no multiple choice. It was just 2 free response questions that each had 10 parts. But you were allowed all these things that you could look up on home, whatever. So I really don't know the details of how they're going to set that up between the 2 types of tests. They haven't said. They're actually quite horrible this year on the fact that they're changing stuff throughout the year as we go. So I'm kind of just doing my best to teach you guys as if you're given nothing and that you're taking it on paper. And then if it turns out to be easier, it turns out to be easier. Oh, but anyway, what I was saying about Khan Academy, last year they got to use everything because they took it digitally at home. I mean, you had to show your work and upload that and everything. So, I mean, like, you can't get more than that for resources, if that's what you meant. So it might just depend on which test you guys choose to take. I would like to find out more before I kind of give you guys recommendations. Oh yeah, in Khan Academy, you guys have 4 days this weekend. Basically, just get through the first derivative test. If you want to go past that, you're welcome to. You're going to find that a lot of the stuff is very similar. But otherwise, I'm just going to kind of start teaching to it next week. And we'll see how it goes from there. So, I don't know. I guess I'm done for today. We'll give you guys a short day and a long weekend. And rest your brain. You're welcome. Have a good weekend.